So what I'm going to try to discuss today, even if it has actually been discussed quite a lot with Patrick earlier on, is the definition of objective quality metrics for new immersive media. So as Patrick was mentioning, there's a lot of ongoing work for subjective assessment. So still, we are pretty far from objective quality metrics. I'll give you some hints and maybe some ideas on how it will be possible in the near future to develop these kind of metrics. So first of all, we are talking about immersive media. So we are dealing with some content that is completely different from 2D, and it has also differences with 3D. So we need to take into account some peculiarities that haven't been considered so far. So first of all, what is immersion? Because everything starts from there. We are talking about something that is defined by Sadowski and Stan in 2002 as the feeling of immersion, whether physical or psychological in nature, allows the sense of belief that the user has left the real world and is now present in the virtual environment. This means that when I'm exploring some immersive content, what I have to feel is the presence feeling. I'm in that place and I don't have contact with the world that is surrounding us. How can this be achieved? Well, there are many, many techniques. And like a basic one can be simply with a 2D screen, or more sophisticated and technological ones, like the one that you see on the top part of the slide. And eventually you can have interaction with the content itself. You can move around your site, see around the things, and this is, of course, an increased experience with respect to classical 2D and even 3D. This gives a feeling of interaction, but not really immersion. But this can be obtained by the use, for example, of head-mounted display. So HTC Vive is something that is largely used, or any kind of this head-mounted display. So you put them on, and you are projected in a completely virtual world. How can you explore this world? There are several ways of interaction. So you just stand still and rotate your head, as Patrick was describing earlier. So you have this kind of feeling that you can explore like a 360 content. Or you can eventually walk. So with the HTC Vive, you have these positioning capabilities, so you can walk like on a treadmill. And I know you have one here in the CIVIT lab. So you can walk in the virtual environment as if it is a real one. Well, this is a lot of stuff to process and introduces a lot of, let's say, freedom and difficulties in assessing the quality of experience. In fact, as Patrick was showing earlier, there is a lot of work that is ongoing, and there's a problem in understanding how also the different techniques that we use to render this immersivity are affecting the quality of experience. So first of all, if we want to go to objective quality, we have somehow to start from the subjective one. So you will find some overlapping with the things that Patrick already said. Let's try to focus more on these objective quality metrics. So as with Atanas, the discussion with Atanas was highlighting, there are actually many, many ongoing efforts. These are just a few of them that I wanted to list. So there are standardization bodies, but also simply, people that are grouping and making their effort trying to define subjective and objective qualities. So for example, the first two are Qualinet is actually an ongoing working group. It was a cost action that ended in 2014, but they kept their activities going. And they have created this task force on immersive media experiences. Same thing, we have a VQX, so Video Quality Expert Groups, that has founded this immersive media group. And parts of the things I'm going to tell you today are actually an outcome of the talks we had with this group in the past weeks. Then we have, of course, JPEG Plano that is dealing with much larger aspects, so many things more than simply quality of experience. Then you have IEEE. Here I have listed two of them. One is the one that Patrick was mentioning. This HFV, Human Factors of Visual Experience. And this is a group we're working on, so we're trying to figure out how to subjectively and also objectively evaluate the quality of immersive media. And of course, MPEG. And there is a joint effort between Qualinet and VQEG trying to figure out how to mix these subjective studies with objective ones. And then there is this ITUT that I really haven't found. I found that it has been built up. It started activities in October, but not really information about the current activities, but it's a group on quality of experience on virtual reality. What is going on in these groups? Well, the first thing that has to be defined somehow are the guidelines that need to be followed to create objective metrics. And the first thing, this is something that we were discussing also in the previous talk, is that we cannot escape from being dependent on a specific task or an application. So what has been discussed in this VQA group I was mentioning earlier is that probably we might consider different groups to like big areas of application or task that can be used. The first one is, we call them unidirectional use case. It means that you have a user that is interacting with this immersive media, but doesn't really have a feedback. Like for entertainment, I can wear my head-mounted display, I can watch around and explore the content, but I don't really have a feedback. Or for training purposes. Then we have a more difficult task, that is the bidirectional use cases. That means that there is an interaction between two parties, and there we start having a lot of more problems that have to be dealt with. So for the moment, for example, we started investigating the unidirectional use cases on the subjective side, trying to move to bidirectional and then eventually come up with a quality metrics for this. Is this fair, to go for specific task-oriented application? Atanas was asking, yes, but there are so many variations. How can you finally say this is good, this is not good? Who will say if this is well done or not? Well, this is something that's been already done, like for VQM, so video quality metric tools that has, for example, 5 models that could be applied in different use cases. So it is difficult, of course. It increased the levels of freedom that we have in the definition of quality metrics, but it's kind of mandatory for this type of media. We cannot escape from the dependence from the specific use case. So what are the steps that have to be followed if we want to create a quality metric? Here there are some rough guidelines. So first of all, and this Patrick was mentioning quite clearly, that we need, for specific use case, that we select a database. And this is one of the biggest problems, because finding suitable databases, and not only simple database, but with ground truth and extra information that can help also to assess the quality of the metric that we have defined, is very, very tough. For 2D images now is okay, 3D is better, but for immersive media, I'll show you later on, it is still a big problem. Then we have to find ways to characterize this content, and I'll come up to this later on for Lightfilled in specific case. Then the definition of quality factors. So if we have some content, what are the characteristics, the quality factors that we want to explore? And I will give you an idea of this in the next slides. Once we have decided what are the quality factors that we want to assess, which is the purpose, what do we want to assess, like the coding techniques, for example, this has to be defined. Once we have clearly decided all of this, and this is also a pretty tricky task, we can actually start building up our subjective experiments, go through a bunch of tests, collect the mean opinion scores, and then check if our model that we have created can actually fit the subjective results. So basically, we cannot escape if we want objective quality metrics for the subjective part. This is where we are starting our work. So first of all, what are the quality factors? When we think about quality in general, if I ask you, what is quality for you? I think that the answer would be most likely audiovisual quality, because this is something we're used to. If you look at your mobile phone, you get like a video, and then you have to say, yes, it's good or not. You're going to go for audiovisual quality, and basically visual one. When it comes to immersive video, there are some other parameters that we should include, of course. The first is the presence, the sensation of being there. So when you have an immersive experience, I think most of you have tried this. You really want to be there, to feel immersed. You don't want a contact with the outside environment. The real world has to be the virtual one. And this is something that's been actually investigated since the 90s. It's not something new. And there are, if you look on the internet in the state of the art, there's a bunch of questionnaires that you can use to assess the feeling of presence of users. Well, there are many questionnaires. We have done some experiments in our university, and I can assure you that it gets pretty tricky to select which one, because depending on how you want to assess the presence, the feeling of presence, and also the questionnaire changes quite a lot. Then the thickness, this is something that it's worth mentioning, but it was already there for 3D. So of course, if we find a way of assessing the thickness and to understand what are the factors that cause the thickness, then we can eventually embed it in a quality metric and help us to predict the subjective opinion. Then also the effectiveness should be included. This is a bit tricky also as a definition, because how effective is the system in providing this immersive media with respect of doing it in real life. For example, for training activities, this is pretty easy to understand. If I'm training, like we're planning to train firefighters for a specific task, how is it to train them in a virtual world rather than in a real world? The feeling has to be real to be effective. And of course, this is also depending on the hardware. And on this side, for quality metrics, it gets a bit difficult to take into account. Once we've done this, so once we have we have selected what are the quality factors that we want to address, then we have to go on what we want to evaluate, which is the purpose of our immersive media. And so, for example, should we take into account the capture system? For those of you who are in the 3D TV Con, we have seen that if we want to record like 360 content, you have several ways you can do that. And changing hardware also changes the quality of the content that you record. So this is one factor that should be considered, and also the post-processing, all the stitching, that generation, and so on are slightly dependent on the capture system that you use. Same thing for the audio. Compression and transport. So this is pretty for you. I think it's pretty easy to guess how this can affect the quality. The display system that we're using, and not only the type of display, but also the rendering system. And I'm going to give you some highlights on this later on with some work we did also with Patrick. And then eventually bidirectional use case. In the bidirectional use case, we have this end-to-end delay. So we need it to be as fluent as possible, because we need it to be real smooth and natural. So where to start? There are so many parameters that should be selected. And first of all, the use case, it gets difficult. So what I want to show you today is like some work that has been done on virtual reality, but basically 360 images. And actually, it's partially overlapping with what Patrick was showing you earlier. And then some work that we did for light field imaging. There is some, let's say, preliminary work on augmented reality, but they were still pretty far from going to subjective and even objective quality metrics. So starting from this subjective part, I'm trying to go to the objective one. So as Patrick was saying, if we want to define quality metrics, we have to start from good visual attention modeling. And this was one of the goals of the Grand Challenge he mentioned earlier that was organized for ICME 2017. And I have to say we participated. It was a very interesting competition. So we started facing the problems that 360 offer. But I think that one of the most interesting outcomes, together, of course, with all these 30 or something visual attention models that are, by the way, online, they've been published. And actually, there is this signal processing and image communication special issue, all dedicated to these saliency models. This is the important factor, the important study that came up from this challenge. So as Patrick already said, It helped us to understand how a viewer actually explores the content. The focus is not in the center. There is this offset of 14 to 16 degrees from the center. And this is extremely important for objective quality metrics, because as he said earlier, there are some metrics that are actually modified versions of PSNR. And this could be very nice to include this model, this attention model, inside the classical PSNR to see what happens and if the prediction of the subjective score is actually good or not. This is not the only outcome of this grand challenge, but together with that, there is a pretty large database, so containing head movement and eye tracking information, ground truth, and this is really important for the community. So I think the main two things to pick up from this grand challenge are these for this year. Let's wait for 2018 and see what will happen next month. So once we have these, how can we exploit it? The classical approach when new media come up, this is something that's been done also for 3D, is to start using conventional 2D metrics. So there is this, the Ibrahimi's group was doing this in 2017. This was a paper in which they investigated the performances of classical 2D quality metrics on this content. So we have PSNR, SSAM, and Patrick was explaining also the problem with this metric and some variations of it. Then we have PSNR, HVS, and HVSM that are modifications of the PSNR that are based on the human visual system, and both of them have been decided here in TUT, so I wanted to present them. And this is like a starting point. Together with that, some new metrics started appearing. So the answer to the question that Sebastian was posing earlier, yes, they are free. I mean, there are 3, 4 of them, and I have some references. Yeah, the code is downloadable, so can actually be implemented. And the first one is the Spherical PSNR that is based basically from a conversion from equirectangular to spherical representation, and then back to equirectangular. And the error that is computed between this representation and the equirectangular one is considered as an evaluation of the quality. It's actually a PSNR, modified PSNR that is used. There are 2 different, let's say, versions of this metric, and they basically depend on how the mapping from the spherical to equirectangular shape is done. So whether it is using the nearest neighbor approximation or interpolation. Then we have 2 more. One is the one Patrick was presenting, so weighted spherical PSNR. That is basically a PSNR in which a weight is added, just to take into account this, let's say, equator bias of the viewers that we have demonstrated with the donut shape that is not really like that, but this metric has been developed in 2016. And then we have a cluster parabolic projection PSNR, CPP PSNR, that is basically PSNR, but only in this cluster representation. That is the one that you have for the world map. So you project the sphere on this, the equirectangular information on this shape, and then you compute the PSNR in this field. What are the results? Where the comparison between the performances of the 2D quality metrics and the doc-defined quality metrics, as you can see, is not so different. So if we use traditional PSNR, that we know that is not the best way to assess quality, and then we check it versus the ad hoc quality metrics, there's not this big difference. Same thing goes for Spearman correlation, and also comparable values of RMSE are there. But is there an explanation for this? Of course, yes, and it's pretty easy. This is due to the fact that, as I mentioned earlier, those metrics, the ad hoc design ones, are basically the modifications of PSNR. So you can see that the trend is the same. And if we want something that is performing better and can actually take into account different characteristics, then we should move from the PSNR and introduce something that is completely new. we are trying to get there, but still there's a lot of work first on the subjective part to be addressed. So this is the conclusions up to now. This is 2017. No recent work has been done on this so far, so probably there's a lot of space for trying investigating these aspects. So this is one part. The other thing is light field quality. I'm not going to talk about light field because I know that there will be Atanas who will talk about that later on. What I'm interested in when we're talking about light field are these capabilities that the use of light field provide. So there is changing viewpoint and refocusing. This gives a lot of opportunity for providing immersive exploration of a content. So this is why I put them in this, let's say, objective quality for immersive media. What is new here in the light field image communication chain with respect to traditional ones is the last block. So we have always our image, preprocessing, coding, distribution, decoding, and then we are here. We have these post-processing steps that depend basically on the way the content is displayed. So in the basic case, we get only the central views of all the available ones in the light field, and we get a simple light field as a 2D image. Or we can take different views and play them in a multi-view scenario, or we can exploit all those other information and, for example, have a 3D representation. Depending on this, we change the way the quality should be assessed. So where to start? We had this discussion with Patrick some time ago, a couple of years ago. So it is, how can we start thinking about evaluating light field? So the first problem we had is how to design properly the subjective tests that have to be carried out. And we said, okay, let's go first, deciding what are the visualization techniques that we want to use, then how to select the content that we will include in experimental result, in the experimental test, and then run the subjective experiment to see how our selection were working. And this is how we approach the problem. So first of all, how can we render light field content? There are several ways, but we wanted something that was easy. I mean, if you are home and you get light field content, which is the cheapest and fastest way of exploring and using the capabilities of light field, is displaying it on 2D displays. So this is the basic. You lose some capabilities, but still it is something that everyone, it's also easy to do on the subjective experimental premises that we have. So among all possible representation, we chose this one. So the extended depth of field, this means among all available view, we took only the central one. Then we had a pseudo video that now stopped playing, but basically we took close views, views close one to the other, and we played them as a video. And then we had refocus video. It means we looked, I'll try to play it again. So the refocus video is not playing, but what happens here, the camera is still, so we take one view and then we refocus at different depths. And so we have a different representation of the content, and then we picked, in this case, randomly refocused images from the available ones. Once we selected those visualization methods, we had another problem. So it is, how can we choose the sources that we want to use? Well, we had this work done in 2017, and we said, okay, light field content is completely different. I mean, it has the characteristics of 2D content, it has some characteristic of 3D content, and still has something more that doesn't belong to these previous categories. So we should consider all of them when selecting the content for our experiments. So we group them in these macro groups that are low-level features and high-level features. And among these, we had like 2D classical indicators that we use, plus, let's say, light field and 3D indicators. For what concerns low-level features, what are we talking about? Basically, like contrast, spatial information, all those features that you can easily extract with many metrics that are already available in the state of the art. And then we went through the attributes that are specific for light-filled content, that is depth properties and refocusing feature that we have seen earlier. When it comes to high-level feature, for 2D, again, it's pretty easy. We talk about the type of content of the scene, indoor, outdoor, natural, computer graphic. While when we go to light field, we had to take into account things that we couldn't find in classical 2D, like the presence of transparencies and reflections, for example. And those are all things that have been included in our source selection. Based on this, what we did is checking up the state of the art and the available data sets. And again, here we went into some troubles because at the time of this study, there were not so many light field databases available for our studies. And we took 8 light field images. And from this, we said, OK, we will compute all the features, all the indicators that I've shown in the previous slide. And this is the results of low-level features for 2D. This is just one example to show that we computed spatial information and colorfulness, and the images that we selected as source content are spread on all this plane. This means that we did a good job because the sources that we were using were kind of were varying quite a lot, and so it was a good choice. Based on this, then we said, okay, let's create, starting from these selected light field sequences, some distortions that can be applied. What are the type of distortion that we can address? Of course, compression and the addition of Gaussian noise. For compression, we use JPEG 2000 HVC Intra. The goal was to apply those distortions in order to have target PSNR values. So we created our data set starting from our sources. We did these modifications, and we used the visualization techniques that were shown earlier. We use an ACR method, assessment method. It means the subject were just standing still and seeing one image at a time with the different visualizations, and they were rating the quality of the thing they were seeing on a scale from 1 to 5, so from poor to excellent. And overall, we had 20 subjects as a preliminary study. What did we find out? That actually the users preferred the extended depth of field. So you have a light field, and what you like the most is the 2D image that is extracted from the central view. And this is basically due to the fact that users we are used to see 2D content, so this was the most familiar way we could see it. But then the second most preferred one, this is actually what we were interested in, is the pseudo video. So the collection of all views, focused ones, and played in this video shape. So we said, OK, nice thing, but there might be a problem. So we selected only a specific collection of views. But as Patrick was saying earlier, if we change the trajectory, then maybe also the quality changes, so we will be in troubles. What can we do? Consider different ways of putting all the views together. So those are the light fields, and we investigated the 6. Of course, this is not exhaustive. This is not dependent on the specific application. So it's like a general indication of how we should show the content to the users for subjective test. What we did this time is not using our content selection method, and this was actually a mistake, and I'll show you why. And we took 11 light field images, this time from a data set that is available from EPFL. So Turaji Ibrahim's group was sharing this data set with ground truth, so it was a pretty large one. So we decided to pick this one, and it is a large one organized in groups. And we picked one image from each group in order to vary the content and some other 2D low-level features. And we used the 6 visualization techniques I've shown here. So pseudo videos, collecting the adjacent, the views, the frames with different ways. This time we had 28 subjects, same quality subjective assessment method, and we used 3 different frames per second. So we wanted to check whether by changing the number of FPS, this could have an impact on the perceived quality. Well, the results say that something that we didn't like that much, but we could still find some conclusions out of it. So first of all, if we go through the visualization techniques, there was a slight preference, we can say, to this PV option, that is this one. While they didn't like at all, they disliked the most, let's say, this NO representation. Okay, this is a spiral. This can be easily explained because when you move in this direction, you actually change a lot. So you have consecutive frames that are changing quite a lot in position and sometimes in illumination. And this gives doesn't give a very fluent appearance to the video. So this was not perceived as a good one. Probably with some post-processing, this could have been better. So we said, okay, pseudo video, the closer are the views, the better the quality that is perceived by the user is. But then we were looking at the mean opinion scores. So as I said, the scores are from 1 to 5, bad to excellent. And as you can see, all of them didn't go over number 3, so over fair. All of them are pretty low. So we started wondering why. And luckily, we had asked also the subjects to give us some comments. And apparently, the problem was on the content that we were showing. So we were investigating, again, this spatial information versus colorfulness, for example. And we found out that all the images that we've been using were kind of belonging to the same cluster. So they were not nicely spread as for the previous work. And this might actually be an impact, may have an impact on the result of the subjective test. So content is still something that has to be very carefully selected when running subjective tests. So what we found out here, that there's a lot of work to be done, further analysis on the content, and we will eventually rerun this subjective test. And there's another aspect that should be considered, the difference between interactive and passive experience. So when you show a video, a pseudo video, even if it is obtained by different views for this light field, it's still a passive interaction. Okay, it's, yes, a passive interaction. I mean, the user can't really choose where to look and when to look at that. So interactivity will be much more interesting. On the other side, assessing the interactivity gets really, really hard because everyone will have his own experience, and it will be difficult then to have a common background and to compare the results that you get if you leave the user to freely navigate the space. So there are many challenges here, and we will try to deal with this in the near future. But first of all, we have to clearly find out all the details concerning the subjective part. So it was like Patrick was presenting the subjective quality assessment. I was this objective one, but as you have seen, there are many overlapping things. And this is due to the fact that objective cannot exist without subjective. And then once subjective is well consolidated, then we can think about abstracting some quality metric that can work without having to run every time subjective test that we know is time consuming and you need a lot of people, and it gets very tough to get those guys coming and sitting and assessing our experiments. So first of all, we need an understanding of the subjective perception, and then there are several parameters that should be considered. Among these, the application scenario, so the specific target use case, the quality factors that we want to investigate, and which is the purpose of our study, and which is the effect on QoE depending on these purposes. And this is an invitation for everyone who's working in this field, and provide your data sets as much as you can. The best thing will be containing ground truth, mean opinion scores, but we can eventually collect the mean scores by ourselves, and eye tracking info. There are efforts there already, like in the ACM Multimedia System Conference that will happen next week in Amsterdam. there are a few years that there is this open dataset and software track. It's very nice because you have people publishing their contents, and they're freely available and can be downloadable. So it's a pretty nice thing. And both Qualinet and BQEG, of course, JPEG Plan as well, have collected a number of data sets. I've underlined this one because those efforts have been going on for quite many years now. So if you go to these websites, you get very, very, very large list of data sets of any kind. With this, I think I'm done. Thanks for your attention.
Your questions, please.
Yeah, I have the problem that all the questions you already answered.
All your data sets were captured with optic cameras, right?
Oh, our data set, you mean are in Roma Tre University? We have one that has been captured with Litro Illum, yes. And yes, it was actually a joint work with Sundsvall University. So with them, we did this database. But it is like a small one, and we found out that there are things that should be improved. All the ones that I have presented here actually are not part of the data set we personally recorded, but they were taken from available ones.
But still everything is from optic.
Yes.
Cameras.
Also, the EPFL data set is taken with Illum cameras. And it's very detailed. You have all the information there to use it properly.
Okay, other questions? So it seems that PKSNR is not that bad for omnidirectional content.
Well, the thing is, yeah, I knew that this question was coming because then the correlation values are not so bad. But then it was 0. But this is not true. I mean, I think it depends also on the content that they've used, because as Patrick was saying, if you move things a bit, then the performances can change quite a lot. So I had other reference papers that were doing this kind of comparison, and PSNR was definitely lower. This one I liked because I had the metrics, the ad hoc design metrics, and.
But then it means that the methodology is questionable. So
that's the point, yeah, also. So this is something that should be investigated. There are so many.
No, but as you stated, it depends also on how you evaluate the performance of the metric.
Yeah.
And the statistical framework that has been used here,
yeah,
let's say, is in favor of some.
Yeah, this is why it was tricky to see the PSNR is so well performing when we have been saying that it's not working. But
okay.